In this session, we'll talk about a case study for robots. You might or might have not seen this particular robots, but those are vacuum robots. Some of them they have fancy names. Some of them, probably the most famous ones, are called Roombas. In reality, you can generate or create some kind of robots on your own. As you can see in this particular example, you just need a Raspberry Pi, a microcontroller, and that chassis that you can actually have some wheels to move north, south, east, or west. We will create the interface that generates this robot. The first thing we have to do is to generate the fields. The fields are the characteristics, what makes this object unique. And there are several fields in this particular item called robot. A robot has wheels, sensors, in order to make sure if you don't have something in front of you, they recognize that. A direction, some have the compass to see where is north or south. Some fancy ones, they have cameras where they can actually recognize object and make a decision based on that. GPS, which help us to find a location in terms of X, Y, or Z. A distance to keep track of how much distance in meters or feet that you have traveled. Some of them they have some LEDs that they give you some kind of feedback when you're actually reading or navigating or when you have to go back to the charging deck. For simplicity purposes, we're gonna focus on the GPS and the distance when we generate this object called robot. The question is how we represent this robot in Java. So notice that location, we're going to have to break it in two types of coordinates, the X and the Y coordinate. X will be an integer representing the longitude. Y, another integer representing the latitude. This can be even more complex if you want to have a double to have more precision. Only for demonstration purposes, let's keep it simple with an int. We also will have distance. Distance will represent a whole number in order to represent the longitude and latitude navigated through this robot. This is very important, especially because if you are on a remote control from the robot, you need to know how much gas you need to put or what kind of energy you should put based on the distance that you travel. Before we jump into the code, let's introduce this notion of UML, Unified Modeling Language. A UML is a diagram and is very important for software engineers and programmers because that will demonstrate a contract of what exactly this software will develop. It's a description of all the objects that you're going to create in the future in any programming languages. Yes, we're using Java, but Java maybe will not be the only programming language that you will use in the workforce. Sometimes even programming languages expire, and we might need to adopt it to a new programming languages. But don't worry, the UML never expires. It also provides the flexibility to write that program in any language. This diagram will describe the fields, constructors, and the methods corresponding to the encapsulation and modifiers. This also includes the data types, the return types of certain methods, and of course the parameters that you need in order to execute in the program. This is the UML for the robot. Let's inspect what each component takes place. The very first thing is the name of the class. This is robot, and they usually put at the very top of that box that you see there. This smaller box represents the fields. These are the characteristics and what makes an object unique. Let's inspect what is inside of there. These are the constructors and methods. These are the functionalities of this object called robot. Let's inspect what is inside of the fields. The very first thing you see there is called the encapsulation modifiers. Java supports a couple of those modifiers in terms of visibility. Public is denoted with the plus sign, private with the minus sign. The difference between public and private is that public methods, everyone can see it once you create a new instance of the object. Where private, they're only accessible by this class, in this case, robot. There's other additional encapsulation modifiers, for example, protected, very widely used when you inherit objects from a different class. Protected allows us to do this separation of duties to see only certain elements can have access of these fields, whereas the rest can be private or public. There's an additional one called package. And package only belongs when you create large programs and then only communicate along those packages or subfolders. This is an example how we retrieve this information in code. The fields are composed by encapsulation purposes. This is private, followed by the data type. We all have integers. So therefore, the data type that should be defined just after the encapsulation type before the name of the variable. followed by the ID. Make sure you don't include any initial value at this point. We're only declaring the fields or the characteristics of the object. The next item are the constructors. Remember that the constructors are responsible to initialize all the fields. Now notice that we have three types of constructors. We have robot, open close parentheses, robot with 2 integers, and robot with 3 integers. Also notice that there's a keyword there called this. This is used to refer that any element defined or used in this particular class called robot. This is very important because it refers only to the items in this particular class. Very useful when you develop mobile apps. Notice that every time we're referring to the fields, we use this.x, this.y, and this.distance. Also notice that every time we're referring to this, it helps us to distinguish between the fields that we provide in this class versus the parameters. This is called shadowing. For example, in customized constructor number 1, we provide 2 parameters, int x and int y. But notice that we also have the fields x and y. In order to distinguish which one you are referring to, this.x is a field, whereas x is a parameter. This.y is a field, where y is a parameter. Notice that we provide a default value for this.distance for 0 because distance is an int. We can also have another customized constructor when we provide all the fields. Notice that here we have x, y, and distance as a parameter, but also we have a constructor that initializes x and y in this class. Is the customized constructor number 1. That's why in this line, we use this open parenthesis x and y. That invokes that particular customized constructor number 1. When you have multiple methods or constructors with the same name, this process is called method overloading. Method overloading allows us to be flexible with the computer user when we invoke a particular method. Method overloading is one of the features of object orientation programming and is widely used in programming. This particular item is invoking the second constructor, constructor number 1. Java is smart enough to recognize where is this located. The next item is called getters, also known as accessors. Getters and accessors permit to retrieve data from the private fields. Very useful. Whenever you are outside of the class robot and you want to extract information, for example, x, y, or distance, let's pay attention how these are defined. The plus sign represents the encapsulation type. All getters usually are public because we want to provide this flexibility to everyone who is outside of this class to access x, y, and distance without any problem. That's why we provide the plus sign. The next things are the return type. Getters have return type. In other words, they're a return-based method that will allow us to retrieve the field data type that we're going to report back whoever is accessing it. Getters starts with the word get. By convention, we use camel case style in order to basically have get and then the name of the field. You can see here get x, get y, get distance that will permit the computer user to access them without any problem. The next items are the setters, also known as mutators. The setters will permit to change the state of the object by updating specific field. This one, in contrast from getters, they do have parameters. Let's inspect what happened. Some setters are often public methods. I know it's a little bit weird to say why you will permit such an action so everybody can access it, but only for demonstration purposes we're creating public. But we don't want anyone to touch our fields. But in this time, we're going to make an exception to providing a public method as a setter. They usually are void method. We don't want to retrieve any information after the change of the state of the variable. Setters usually start with the word set, followed by the field that you want to modify. In this case, we use camel case style as well to set x, set y, and set the distance. And finally, setters, they do have arguments. These parameters allows us to change the state of the object by providing that parameter and modifying the current field. You can see here we're modifying this.x by providing the parameter provided there as x. This.y gets y, and this.distance gets the distance. Finally, we have more methods that will allow us to perform some functionalities. We're using the robot, and the robot has X and Y in distance, so might as well have some mechanisms, some functionalities that allows us to manipulate those values of X, Y, and distance. You can see right now that we have a couple of them. For example, we have move north that will allow us to move the Y coordinate by 1. Notice that the distance is also being increased because every step we move to the north, it will increase distance. As a matter of fact, distance changes in all of them. As you can see, move south, move east, and move west. They all manipulate the distance. The only difference is between north and south is that one goes to the north, one goes to the south, and one increases and decreases. Where move east and move west, you manipulate the X coordinate. The last element that you can see here is the toString. The toString is a special method that we inherit from our super ancestor called object. The toString will provide us this textual representation of the object. We usually manipulate different fields. In this case, for example, X and Y. You can see here how we use the power of concatenation in order to provide that good output. The distance is also provided, so it can give us a very nice description of how much this robot has traveled. What we can see here is the class object. Object is the superclass of all objects in Java. Object is the parent of any object you can believe it. Option pane, scanner, string, those helpers like integer and double, print writer, file writer, math, you call it. So here what we can see, one method in particular, equals. We have used equals on string, but interestingly, we can see here toString. The toString is one of those 11 methods that we inherit from the class object. And notice that the return type to the left-hand side is a string. Again, it gives us a small description saying that this returns a string representation of the object. And we have seen this in the past. Let's recall. This is the main. When we create an instance, as you can see on line 3 of robot, we create this by using the default constructor or the non-argument constructor. The only thing we're trying to do, or we attempt to do on line 4, is to print raw, which is the instance name of robot. Notice that we haven't declared any toString in the class robot. Let's see what happened. If I save, compile, and run this program, we're gonna get the following output. This looks familiar. The first part is the name of the class, followed by this @ sign that is basically mentioned that is located at this funky address. This is the hexadecimal address location where the object is located. We have seen this in the past with arrays. But what happened if we define a toString in the class robot, similar to the one that we show in the past? Well, if we save, compile, and run this program, we get a very different output. Now we have the distance, the value of X, and the value of Y. Notice that we didn't do anything different from robot demo. This is more informative versus the other one. Which one you prefer? The one without toString or the one with toString? Well, if your reality just don't care about the information of our robot, maybe you don't want to override a toString method. But if Granny is using your robot that you create, maybe you want to give a very meaningful representation of this object, which is the lowest part that you can see here.